syntax as AD only. Now, apart from that, generally we will have one VCC and one ground. But in this case, although the VCC is one, you will see that there are two grounds in this 8086 processor. So pin number 1 and pin number 20, both are ground pins there. So now we have to see all these pins. Then you will also see in the figure pin number 24 to 31. 24 to 31, they are having dual purposes. Means one set will function at one particular time, another set which I have shown to the extreme right, they are all functioning at some other instant of time. We will discuss this situation when it arises as we go through each of the pins. So now to start with the easiest one, your address data bus AD0 to AD15. Now in this AD0 to AD15 means there are total 16 lines. Although the address bus for your 86 has got 20 lines. So 16 are used as data lines also. And then on the top, if you see the pin diagram, in that the pin number 38, 37, 36, 35, they are AD16 to AD19. So those were the other 4 pins which we are not using it for your address bus or the data bus. But we say address bus is 20 lines. The 4 lines are used for some other purposes also. So you can see there AD16 slash S3, S4, S5, S6, S7, those are status signals. So one by one, you have to go on discussing when you are asked to write or discuss about the pin diagram. So as I said, address data bus AD0 to AD15, these are time multiplexed. This particular word, time multiplexed, means for some interval of time, they will be used as address bus and then later it will be used as the data bus. So that is why it is said time multiplexed, because it is used for multiple purposes depending upon the time. So initially the address is put on the address bus, then it will go to the memory location, and then from there it will fetch the data. So that same bus will act as the data bus also. Now, when it acts as a data bus and when it acts as an address bus, that is also designed for the microprocessor. So you have always what is known as a clock signal also, and depending upon the cycle of that clock, the time will be decided. So if the first time cycle, in the first time cycle, the lines will carry the address. In the second time cycle, it will carry the data information on that same lines. So that is why when it has to carry and when it has to take address and when it has to take the data, there is also one more signal which is known as ALE, address slash enable. This particular signal you have come across this even with the 8085 processor also. So one by one, if you see, already I have mentioned there, the 8086 has 20 lines for address bus and 16 data lines, but AD0 to AD15 are time multiplexed data address data lines. So AD stands for address data lines, and it can be separated. Means I said for a small interval of time, it is used as address, and it is also depending upon the address latch enable signal. So whenever that address latch enable is 1, then it carries the address, and if it is 0, it carries the data. Now this address latch enable has got one more function, that is with your address status lines. So earlier one was address data bus or address data lines. Next one is address status lines. So here your address, what I mentioned in the figure, that AD19 to AD16, this is simply it is used for the address bus. So that is why it is denoted as A19/S6, because that particular pin has got two functions. One is to do with the address line, and the other one is to do with the status line. So you are having four again time multiplexed address status lines. The four address status lines are denoted as A19/S6, A16/S3. And it can again be separated by your address latch enabled terminal. So when the address latch enabled terminal is 1, it carries address. In the earlier case also, when ALE is equal to 1, then it carries address. Now, in the earlier case, if ALE, sorry, that is a mistake by me in the earlier case, it is ALE, not AEL. So ALE, when it is 0, once it is carrying the data, another time it is to do with your status signals S6 to S3. Now, every pin is having some or other function. Now, how these status signals are used, that is mentioned again here. The status signals S7 to S3. If you see your pin diagram, in that you will see pin number 34 that has got again a dual function. It is BHE bar slash S7. We will come to that bus high enable little later. Initially, let us discuss with the status signals. So now your S7 to S3, all these signals, they have got what is their work. So you can see S3 and S4 status signals, they will indicate which segment is accessed by your 8086 during the current bus cycle. Now, in the block diagram, you have come in your bus interface unit BIU across the segment registers. So now selection of that segment register is also based upon the value of S3 and S4 signals. So as you can see in the figure, for the state of S3 and S400, your extra segment is selected. And when it is 10, your stack segment is selected. When it is 01, it is code segment, and 11, it is data segment. So like this, for different values of S3, S4, you are having different segments which are assessed in your 8086 processor. Now, next, after S3 and S4, you are having S5. S5 status signal will reflect the IF flag register. So this is interrupt flag register. So it is having interrupt flag register in itself is having some work, but if you are selecting to select the flag register itself, you will have the status signal S5. S6 is always kept 0. S7 is always 1. So there is no dual function for S6 and S7. Permanently S6 is 0, S7 is 1. Now this we will come again little later how this is used in connection with the other functions of the processor. Now BHE bar slash S7. So as you can see, the full form of BHE is bus high enable. Now this line is used to enable your data lines. Which data lines? This is the higher byte of the data lines. So D15 to D8 will be higher byte of the data lines. So D0 to D7 is lower byte. After that, D8 to D15 is your higher byte. So to enable that, they will use further. One more work with this will be, it is used in memory banking means, I told you that earlier while discussing the block diagram, with the 20 address lines, you are having 1 MB of memory location. That 1 MB is divided into two different banks. And the odd addresses will be from the lower bank, will be from the odd addresses will be from the lower bank, and the even addresses will be from the higher bank. So when you are using that higher memory bank, you have to enable those higher byte of address lines. And so for that, you need to provide one specific signal. So that is why this bus high enable signal will be used if you have to access the higher memory bank of your 8086 processor. So this is how the BHE bar signal is used. S7 is always kept 1. So let us say by default it will always remain 1. Now next one is your non-maskable interrupt. So this is pin number 17, non-maskable interrupt in your pin diagram. Now non-maskable interrupt means whichever way you want, you cannot mask the interrupt. Means if the suppose I want to give a command say print from the input device. So even if some program is running on the processor, it will stop that program and it will take my interrupt, that is my print command, and it has to execute. So it cannot mask that particular command from the input device which is given. So masking means to suppress. That is as simple as that. So hence it is used to give the highest priority interrupt to the processor. Now, as I said, it cannot be disabled even by the software. Once I am saying print is only one example for you to understand. It means it has to execute that particular operation. Now, it cannot be disabled even by software also. So after you give the print command in the program, you cannot say stop printing. Is there any such command? So some of you must be familiar with C language also. There also you cannot do that particular stop printing type of work unless you have to reset your processor. So now this command, non-maskable interrupt, it will be executed on the positive edge triggered interrupt, it is said. So in the figure you can see positive edge triggering means when your clock signal goes from 0 to high, it is going towards the positive edge. So it is known as positive edge triggered interrupt. Now interrupts can be of different types. It can be positive edge triggered or negative edge triggered, or it can be level triggered also. So here this non-maskable interrupt works with a positive edge trigger. So whenever that nothing but when the clock pulse goes from 0 to 1, that particular interrupt will be acknowledged. Means the processor will execute that particular command or the function which the interrupt signal is requesting. Now next one is interrupt request. This is also one more hardware interrupt only. Now in this what happens? In the earlier case also 8085 also you had this INTR interrupt signal, and this is first thing is from the name itself you can understand that it is an interrupt request, and this one is level triggered means you can see when the signal remains stable at logic 1, your clock pulse, all your clock pulses are square pulses only which you are giving. So as long as it is remaining in that high state, this interrupt request will be taken into consideration by the processor. So it depends on the status of the interrupt flag. So I told you in the beginning, S5 reflects, that is the status signal. It reflects the IF flag register. So now you can see how your interrupt flag register will be used. So it depends upon the status of the interrupt flag. Now, if the interrupt flag is 1 and INTR is also active, so it is 1, the microprocessor gets interrupted. So non-maskable interrupt doesn't need any condition to get executed, but INTR interrupt has a condition. That condition is the interrupt flag should be equal to 1. But if the interrupt flag is 0, then the INTR interrupt will not be executed. So then INTR is disabled. This is what it means. So this is about your interrupt request. Now next is there is an interrupt acknowledge also. So once the printing of whatever material is done by the printer, it will send a command to the processor no, once the interrupt signal goes and the processor acknowledges, then it will send a request to the printer, and then the printer will take that request and send the INTA saying that yes, I have seen your request, I am ready to do the work which you are requesting. So this is the understanding or handshaking which takes place between the processor and the output device. Here it is printer being an output device. Along with the interrupt request on INTR, microprocessor gives the interrupt acknowledge to the peripherals. INTA bar, it is pin number 24 in your pin diagram. Now, sorry, it is an output signal, so the processor only will send an acknowledge signal. So here, microprocessor gives the interrupt acknowledge to the peripherals. So the processor is sending the acknowledge signal to the printer there. So since it is an output signal, similarly, the printer will also send an acknowledge signal. In the handshaking signals, you will see this. I think we have discussed this with 8085 processor, and this discussion took place in the class also. Handshaking signals between different devices which are connected to the processor. So processor gives some signals, and the device to which the request is sent, that also gives some signals. So that is how an understanding takes place between the processor and the devices. Now next one is system clock. Now in this is also one peculiar feature about your 8086 processor. So as you know, the clock is given for internal timings, means for one instruction to execute in one machine cycle will have some few number of T states, what we call. So one T state means the address is placed, and then the next T state, the data is placed on the address bus, then the instruction being executed, then the result being again shifted to the memory. So all these sequence of operations will take place as per the clock cycles which are existing in a particular machine cycle of that particular processor. So the clock is given for the internal timing. So you need not write all this story there. You can simply say it is used for the internal timings of the processor. And your 8086 processor, it can have a clock with a frequency of 5 megahertz or 8 megahertz or 10 megahertz. So possibility is there that you can have different clocks. And still your 8086 will be compatible with all the different frequencies of the clock. So the design is set in that way. Now next, coming to this minimum and maximum mode. Now in the pin diagram, you are having pin number 33. I showed you in the pin diagram that on the extreme right side, there are few signals which are having, that is from pin number 24 to pin number 31, they are having dual functions, and that dual function is based upon this minimum and maximum mode. Now for the minimum mode, this point is little important when you are writing about the pin diagram. Whether you miss one or two doesn't matter, but minimum and maximum mode is an important feature of 8086. So you have to stress on this point there. In your material also, they have given different tables for minimum mode signals and maximum mode signals, and what all those work all those signals are doing, that also they have discussed in that. Now for the minimum mode, this MN/MX bar, it is connected with VCC. So always either that particular pin will be at logic high or it will be at logic low. Now if this MN/MX bar, MN is minimum, MX bar means maximum. So if it is connected with VCC, means it is logic high, then the 8086 will work as a single microprocessor. And if it is connected to ground, then it will work with multiple coprocessor. Means there is a chance of having many number of processors which can be connected to this particular processor, the main processor. Now, the signals which will be used, they are different for the minimum mode as well as the maximum mode. We will not go into the details now only. We will come to that point little later. But remember this point, when it is connected to VCC or it is at logic high, it is used in the minimum mode. And when it is connected to logic low, it is in the maximum mode. By minimum mode, we mean that only a single processor is working. Maximum mode means it will have something like a fan out feature. It will have many processors which are connected to this processor. Now, next one is the ready signal. Now, the input is used to insert the wait state into timing cycle of microprocessor. This is also a new feature which is existing with your 8086. Now, what is this wait state? See there, sometimes what happens when you connect certain devices with the processor, then sometimes the devices may be slow. They may not operate at the speed of the processor. So in such a situation, the mismatch of the functioning or the cycles within the processor should not take place. To avoid that mismatching feature, it will insert a wait state so that the peripheral which is slow will be able to cope up with your processor. So that is why the wait state will be inserted into the microprocessor. So the input is used to insert the wait state into the timing cycle of the processor. If the ready pin is at logic 1, it has no effect on the operation. And if it is at logic 0, it will enter, the microprocessor will enter a wait state similar to the idle state. Means there the processor is waiting. So it is same meaning as it is designed to work. Now, so logic 0 means it will insert the wait states or idle state into the processing of the microprocessor. So as I said, it is used to synchronize the low peripheral devices. Now next one is your read signal. Obviously you will have some read, write. These are other control signals which are always present in a processor. Now if it is at logic 0, since it is active low, RD bar it is. If it is at logic 0, then the microprocessor reads data from memory or IO devices. Now, memory or IO devices, that is also two different things. So you are having a pin there, which is M/IO bar. So if it is M, then it is a memory, and if it is IO means it should concentrate on that IO bar signal. So it should either read from the memory device or read from the IO device. Now, next one will be your system reset. Now, we all do some reset operations even with our cell phones and your processors or your laptops which you are using. Now, here you can see a very beautiful feature which is included into 8086. This input will reset the microprocessor. Obviously, reset pin means it is used to reset the processor. Now, if it is held at logic 1, for minimum of 4 clock cycles, it is not 1 clock cycle. Please see that point. For 4 clock cycles, then only the microprocessor is getting reset. Suppose by mistake, if you press that reset also, it will not be activated because it is designed to wait till 4 clock cycles, then only it will get reset. And that too, that particular pin is made to go at logic 1. So it is at VCC. Now, after reset, what happens? Suppose reset is taking place. First of all, it should be at logic 1 and it is taking 4 clock cycles to go into the reset state. And then after reset, what is happening? So what we assume that everything will become 0. And again, when we start, it will start fresh. But here the situation is not like that. In this, one example is given. After reset of 8086, CS, that is the code segment register, and IP means instruction pointer. These are initialized to. See here, it is not going to 000 state. CS, that is your code segment register, is going to 4Fs, and the IP pointer is going to 4 zeros H. So now what will be the physical address? What will be the physical address where it has to start? So the physical address will be 4F and 0. Now, how to calculate the physical address? There is one small relation for this. The relation is segment register value into 10 plus offset pointer. This is how it will be able to calculate the physical address. So I have come across this word physical address earlier when I was talking about the segment register. Here your segment register is the code segment register, because the code segment register is initialized to 4Fh. That is the maximum value which you can have with your 16 address lines or 16 data lines also, or 16 lines, be it address or data. So now your segment register is your code segment in this example, and your offset pointer is your IP. IP is at 00 and code segment is at 4F. So if you substitute in that relation, you will get the physical address location as 4F0. So this is how the reset will give the physical address for this particular code segment register. So if you want to show the example, you can show, otherwise you can leave that and then say that after reset the code segment is initialized at 4Fh and the IP is initialized at 00H, so that the physical address will be 4F0H. Now next signal is your test signal. So yesterday in the instruction we have come across this test. Test instruction is one of the logical instructions which is present. So it is used for synchronization. Now, how it is used for synchronization is when this input, since it is, can you mute from your side? So, how the test signal is used for synchronization is, this is an active low signal. So when it is at logic 0, it executes the wait instruction. So the wait states are introduced into your timing cycle using the test signal. This is about your test signal as a pin. It is pin number 23 in your pin diagram. Next is your power supply. So all will have a power supply which is as usual 5 volts DC supply, and pin number 40 corresponds to this. Then as I said, it has 2 ground pins, and these 2 ground pins are used to have a lower power dissipation. To have lower power dissipation, you are having 2 ground pins. So much we discussed about your pin diagram. Now if further, if you are interested in writing about the minimum mode and the maximum mode, then you have to discuss about those pins separately also. Now, sometimes they are also asking about the minimum and maximum mode. So if it is asked, it will be in a short answer only to discuss about the minimum and maximum modes. So you can see your material also, which is given there. So when the minimum mode is active and when the maximum mode is active, you give that condition of Mn/Mx bar when it is at logic 0 and when it is at logic 1, what is operating. And then those pins which are used for the minimum and maximum mode, it is discussed in the tabular column itself, what function it is going to do. And regarding the state of that particular pin, whether it is input or output, whatever, how much you can see from the pin diagram also, you will understand whether it is an input pin or whether it is an output pin. So if you can remember the direction in the from the pin diagram, that also you can mention. So now coming to those signals which are with your Mn/Mx bar. So you can see in the pin diagram, you are having hold, acknowledge, then write bar. So hold is holding a request, hold acknowledge is HLDA, And then write, you know very well that it is a write control operation. And then M/IO bar will be IO/memory control. DT/R is your data transmit/receive. So from the syntax you can understand that is a transceiver function, means it is transmitting as well as receiving, transceiver function. So it is a data transmit/receive. And then DEN/bar it is there. This is data enable pin. And then you are having BHE/S7 it is. So sorry, there I wrote it as a suffix there. It is S7 status signal. So bank high enable / status line S7, and then address latch enable INTA. These are the pins which are coming in the minimum mode when your MN/MX bar is at VCC. Now similarly, maximum mode, you are having RQ there, RQ/GT. So RQ/GT0, GT1. These are two different signals on par with your hold and hold acknowledge. So RQ is your request and GT is your grant bus access control. So to use the bus also, there is a signal which is given. So that is grant bus access signal, that is given the notation GT. Now GT0, GT1, these are the two signals there. And then lock is bus priority lock control. Bus priority lock control. So depending upon the priority, this particular bus is going to see. Actually, if I go into the details of all these things, minimum mode, maximum mode is again having its own block diagram. So I thought for your level and the syllabus which is there, I thought only discussing about the 40 pins will be enough for you. In case they are asking you minimum mode and maximum mode, you can simply write the condition and write what those particular signals or control signals are doing. That much you write, that is enough, I feel. Because again another block diagram for all these minimum state, maximum state, they are connected with some more ICs. You have to discuss about that also, how it is used. So that is why I did not go into the details of all these things. You also see what all these pins, how much material is given in your this thing. That much is enough for you to write in the exam. Don't go much into the details of it. Simply you try to see what are the different signals which are present for you. Similarly, you will also see there is one QS0 and QS1. And again for this QS0, QS1, since there are two signals, you will have 4 different states. Those 4 different states that is being discussed. So you also discuss only that much. You also can put like that only one tabular column and write the states of those 2 signals and what function it is doing. That much only you write and you can leave it off. So this is what I thought, this much is enough for your pin diagram, because in exam, since you also have to adjust the time and write this much, draw the pin diagram properly and discuss what all is needed about that pin diagram. Don't go much into the details because that much time you will not have. If they are asking separately about the status signal or the dual function of any of the pins, like I saw one question in your material only, they have asked to discuss few pins. That much only you have to discuss. Where it is? On the page number 261 in my this thing, see there, it is explain the meaning of following signals of 8086. That is RD is your read, S2, S1, S0, then NMI and lock. So you are supposed to know the different signals, how they are functioning in your pin diagram. So I thought whatever information is there along with the information in the tables of your material, that much you see, that is enough for the pin diagram. Now, anything more you wanted to know, then I will tell. Otherwise, this much on 8086 is enough.
Ma'am,
No, tell.
doubt. In maximum and minimum, there is a bar maximum, but not in minimum.
See,
So
see what will happen? What will happen? See this point here. For minimum mode means MN we are saying. Minimum mode, it is connected to VCC, I said. Is it not? VCC means it is at logic 1. Means your MX, it is bar. If it is at logic 1, then 1 bar will become 0. Whenever you are seeing like this MN slash MX bar or any other thing like AD, you had AD9 in the pin diagram AD17 slash S4, is it not? Then 1 and 0 will denote two different conditions. So syntax is MN. MN means minimum, but MX bar means even if that particular signal is 1 means it will take 1 bar, and for 0 it will be active. So minimum by syntax we understand that it is a lower value.
yes, ma'am.
And here another one more thing, by minimum you should also think it in the way that it works as a single processor. So when it is maximum means it is having multiple work there as multiple coprocessors are connected. So when that is connected to ground means 0 bar will become 1 there. So don't think about that MX bar as different thing. Simply you can take MN slash MX bar is at logic high, it works as a single processor. When, see, pin is same, is it not? The pin is same, whether you are giving it to logic 1 or you are giving it to logic 0, that is deciding the operation there. This is only a way to remember that it is used for the minimum maximum mode. Read and write, you have got separate signals. Similarly, your memory and IO, when you are addressing memory, it should be at logic high. And when you are addressing IO bar it is, means it is active low signal. Don't go into all those complications. Simply you write there as logic high, it is used as single processor. Logic low, it will work with multiple coprocessor. Because see here, you are not having, there are many pins which will have states 0 and 1. So to remember this so much, if you are able to remember, that is well and good. You should take less train and give more output. That is what is the intention behind telling all these things. So simply by this one lecture, you may not get all these things because it is slightly different when compared to your 80. Similarly, now again you are having 286 processor, 386 processor, that is also there. And compared to your 8085 and 8086, those advanced processors to 286, 386 and 486, their pin diagram is also little complex only. But then again, you have to look on the important features of those processors. How it is different from your 85 and 86. So if in your material also block diagrams are given, you can see those. They are all very complex. So I was thinking that it is better for you to concentrate on little easier chapters rather than the complex block diagrams which you will have to draw when a question is asked to discuss about the block diagram, means you have to draw the block diagram. So that was my opinion. If you can do, then it is very good on your part. Any more doubts if you are having, you can ask, because I am not going to start anything new today. With 8086, I want to stop for today. So next, which topic will we discuss? Just go through your material and then tell me,
ma'am. Good afternoon, ma'am.
Yes. Good afternoon.
Ma'am, they're asking 5 marks question for minimum and maximum modes. We have to enlarge that matter and draw the table. What is the given in our material? We have to write
that much you write.
only.
See, when minimum mode is active, when maximum mode is active, in minimum mode, what signals are you going to, like, see there, pin number 24 to 31. When you are using this 24 to 31, in which mode you are using?
That all pins we have to explain.
See, first of all, what is minimum and maximum mode? Just now I said, no, when it is logic high, it works in the minimum mode. When it is logic low, it works in the maximum mode. First,
okay, ma'am.
That is there in this. I will share this material with you. You can see that also, because clarity of understanding you will get better when you go through this material. You want or you don't want? If you don't want, it is okay, no problem.
Send in the group, ma'am. It's
yes.
Thank
So see there, you have to write first about pin number 33. Minimum and maximum mode is operated depending upon the status of pin number 33, which will determine the mode of operation. Now, when it is logic 1, minimum mode is operative. By minimum mode, we mean that only one processor is functioning, and in the maximum mode, you can have number of co-processors, and then the signals associated with the maximum mode, they are that QS0, QS1, S0, S1, S2. Now, there are tables in your material, S2, S1, S0, for 3 different conditions. For 3 different signals, there are some conditions, what value it will hold, and depending upon that, the operation is there. So, if you are seeing your material now, when I am telling, all those different tables which are there for minimum and maximum, that you put and you write. So that that much is enough for your 5 marks question. Because this is much more, just as your 8085. 8085, they have dealt in detail in that. But 8086, only architecture, pin diagram, addressing modes, instruction set. So within that only they are asking you to discuss some blocks. That is what I have understood from the questions which are there and the syllabus which is given. But when you are studying, you have to compare them. Now, this 8086 pin diagram you are seeing. In exam, when you are going to the exam, it is possible that you may confuse these pins with that pins. So you have to put both the figures side by side and then you prepare for your exam, so that you should be able to remember which pin belongs to which processor. Because some pins are same there, just as your reset, then memory IO, read write bar. So some signals will be similar there. Anything more you want to ask, you can ask. Otherwise, we will stop now. I will stop sharing and I will give this material to you.
Okay, ma'am.
because you will have another class also. If you are reading and if you are having doubts also, you can ask sometime whenever we are on the class.
Ma'am, 8085, you told that class in the offline classes, ma'am.
Yes.
Completed that,
Yes.
ma'am.
Yes. Yes.
Okay, ma'am. We are not
So I
attending.
finished that in the offline because people can understand nicely, I was thinking. But offline also hardly I had students there.
Okay, ma'am. Thank you, ma'am.
You read, if you are having doubts, you can ask. We will try to help you out.
Okay, ma'am. Okay, ma'am.
Okay,
Thank
then I am stopping the sharing and also leaving the meeting. Thank you all. I thought
Thank
I
you,
will finish the pin diagram. That is why I have taken. Otherwise, I would have not taken this today. Okay then.
Okay, ma'am.
Thank you. Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am. Thank you, ma'am.